So the title of this talk today is Managing Kubernetes with Istio. But before we get started, I would like to get a quick level set, what we have in this room so far as like knowledge and talent goes in terms of microservices. So first things first, who here is dealing with microservices in their day-to-day job? Perfect. Who are dealing with containers, be it Docker, some sort of container? OK, cool, really cool. Container orchestration, Mesosphere, console. All right. Finally, Kubernetes. All right, so this is going to be great because Istio fits right after Kubernetes. Today's agenda, we're going to learn what service mesh is, why does Kubernetes need something like a service mesh, and how does Istio help manage Kubernetes. My name is Mofi. I'm a developer advocate at IBM. I mostly do container stuff, collect stickers, and write Go code, and not in that particular order probably. You can find me anywhere on the internet at moficodes. So if you need to have any question and have to yell at me or anything in that range, please find me either after this talk or on the internet somewhere at moficodes. So before I start this talk, let me preface this by saying Kubernetes is great. I love Kubernetes. Among many things, Kubernetes keeps me employed, right? Because I deal with Kubernetes. And so Kubernetes is great before I say anything else about Kubernetes. Because it's great because it gives us all these things by default out of Kubernetes. So all these different features, Kubernetes comes out of the box. These are great. So why this talk? I mean, the talk mainly is because Kelsey Hightower's tweet that Kubernetes is not the end game. It's a platform to build other platforms. Kubernetes will give you a good place to start. It will give you a base point to build other things. But it's not necessarily going to be the last thing you do in your organization. So Kubernetes on its own is not enough. And that is kind of the main reason all these other technologies are popping up every day. Cloud-native application that we're trying to build needs certain things. And among many of those things are traffic management. So with Kubernetes, you can easily get someone with a load balancer, someone to come to your application. But how do you manage that traffic then going to different versions, east-west traffic through your services? That is not as easy in Kubernetes by default, just using Kubernetes primitives. Observability, Kubernetes doesn't really make any opinion about how would you get your metrics and logging out of your Kubernetes servers. You have to kind of do that on your own. Policy enforcement, so Kubernetes, again, does pretty well in terms of spinning up your application, making people access it with a load balancer. But how do you then manage your policies through a cluster level? Kubernetes doesn't really have a really good primitive to handle that either. You can do some network level policies with Calico or Weaveworks, but or Weave, you can really do anything more fine-grained on the policy level. Finally, security. I mean, almost everyone forgets about it until the day of release. But security is also another feature where Kubernetes doesn't really give you much primitives to handle a lot of the things you need to handle. So what do you need to do then, right? So if you want to have ingress and traffic management, you could use something like Nginx. You can manage that yourself. For tracing and observability, you can use something like OpenTracing or some other tools in the same realm. For metrics, you could use probably something like Prometheus, get Jaeger, or like Grafana to get the logs and metrics into a nice dashboard. Or for identity and security, you can use something like a Vault and get security and secrets passed to your application. So that's a lot of work, first of all, because we have to manage Kubernetes, right? Even if you're getting a managed Kubernetes version from somewhere, you still have to do a lot of things to make your application run on that particular platform. And then we have to manage these 4+ third-party tools. And depending on what you need, it might be even more things you have to manage. That doesn't seem right, right? Like Kubernetes was supposed to be the greatest and the best thing in the world. You put your application up there and forget about it. Everything just works. And now I'm telling you, you need to do even more things. So what do we do then? There's one option we could do. Give up, right? We chose Kubernetes, best in the line, and that wasn't enough, so might as well just call it a day and go home. So we just like sit in this house of fire, let everything burn down to ashes, and because we tried. It tried so hard, but still didn't succeed. But hopefully all of us here in this room are problem solvers. We see a problem with something, and we want to like solve that in some way. So we choose probably option 2, manage it all. 4+, 10+ different services come in. We're going to just have engineers solve this problem one at a time and eventually get it working. But it's not going to be the first time we did it. I mean, Kubernetes came out about 5 years ago. In June, it's going to be 5 years old. But before then, we still build application. And we recreated wheels all the time. Like every organization did their own things for handling all the things Kubernetes gives you now. Like if you remember this particular slide a couple of slides ago, all these different things Kubernetes gives out of the box, we had similar things being built at every organization to some degree. Maybe as a code instrumentation or as scripts, or maybe even as some hardware level checks to get all these different things. So yeah, so anyone who remembers like their 5-10 years ago how they built things, they did some similar things. I don't think skill is the issue here. I think time is. If you have limited time, you want to allocate that time that will give the best value out after spending that time. So you could technically build all these things yourself, but would it be the best value for your time? That is the question. So option 3, to get the things we want to get, use a service mesh. Now you might be wondering, if you don't already know, what is this service mesh thing I speak of? So service mesh, that's the number one thing about service mesh. None of the things service mesh does are magically new or like changing the entire world kind of a thing. These are just collection of best-in-class solutions that already exist. Service mesh gives you a nice way to package them in one bundle that you can deploy and use it in your application. It allows you to control and monitor service-to-service traffic. And finally, and this is the best thing, if you're using a service mesh in your application in Kubernetes, your dev team wouldn't necessarily need to know what service mesh is doing for your application. They will just write their application exactly they were writing the application, and service mesh will happen on the network level, on the outside of your application. So Istio happens to be one of the service meshes that's out there right now. Other options could be Linkerd, Buoyant. So Istio is one of them. It's an open source project that started in between Lyft, IBM, and Google. So in Lyft, they had the project Envoy. And Envoy is a big part of what Istio can do, and association with other industry leaders like Red Hat. Now Microsoft is also jumping in. So Istio has all these different companies working together to make Istio the best service mesh possible. So what does Istio have then? So on the bare minimum, Istio has these 4 things. It has Envoy. You can actually replace Envoy proxy if you need to, but by default, Istio comes with Envoy proxy. It comes with Mixer, Pilot, and Citadel. Envoy is a sidecar proxy that goes within all your pods as a sidecar. Mixer then enforces access and collects metrics from the Envoy proxy. Pilot is the tool that propagates configs to your sidecars. And Citadel does service-to-service authentication and sends TLS certificates to different proxies. So features of Istio. So we talked about 4 things cloud-native applications need. Traffic management. So in traffic management, Istio gives fine-grained control with rich routing rules, retries, failovers, and fault injections. For observability, you have automated logs. So your application code, without changing your application code, you can collect metrics from the network level. And it also generates traces for distributed traces for all traffic going through your cluster, both east-west and north-south. For security, it has identity-based security, and you can enable mutual TLS between service to service. So one more fallacy we have is that I'm thinking anything inside my cluster is secure. But with Istio, so the new idea is that there is no trust in any service that you have. Anyone could be a bad actor. So with Istio, you can enable mutual TLS even within your cluster to service communication. And finally, policy enforcement. Istio allows you to enable policy to deny or whitelist certain things in the entire cluster, enable quotas, and rate limits. So how does this all work? So this picture may look familiar. You have, in your Kubernetes cluster, you have 2 services running, service A and service B. And let's say service A wants to talk to service B. In a Kubernetes world, service A will just make a named call to service B, and the Kubernetes DNS resolver will then find service B if it's in the same namespace. In Istio world, it works a little bit differently. So in Istio, using IP table rules, every time service A wants to talk to anything else, the proxy that is in the same pod will then catch that request, and that pod will make that proxy will make the request to something else. And when that proxy is trying to talk to service B also has a proxy that will catch the incoming request. And between this transport, the proxy can handle HTTP1, HTTP2, gRPC, TCP, or WebSockets, anything you need in between. So how does this work? Magic. Well, those of us who are non-believers and wants to know exactly what happens, that's the Envoy proxy that Istio uses. And Envoy proxy handles dynamic service discovery, load balancing, HTTP2, gRPC, health checks, traffic splitting, and all these things. And you can actually use Envoy even if you're not using Istio. Envoy is also an open source project on its own, but Istio basically just wraps Envoy and adds other features on top of it. So let's continue talking about it. So this is a service-to-service communication within your cluster, but when you're talking about an application, most of the time you're not necessarily inside the service, you're somewhere else calling the cluster to get something. In Istio world, that would look something like this. You have a request coming from outside, and you have a proxy on the edge of the cluster that will catch your request coming in, that will route your request to the server it needs to route to. Let's say service B needs to talk to an API somewhere else in the internet. It will also go through a proxy so that it can check for if you have a policy against that particular API you're calling. So you can control traffic coming into your cluster and also traffic going out of your cluster. And so far we talked about the top part of the image, that was the data plane. In the bottom you have the control plane. That's where your pilot, mixer, and citadel sits. Pilot sends config data to the proxies. Mixer collects metrics from the Envoy proxy, also checks if there's any policy against the thing the proxy is trying to do. The Citadel then sends TLS certs to different proxies. If you have mutual TLS enabled, you can have Citadel send the certs to individual proxies so that each request can be checked against a certificate. So traffic management, again, you have ingress and egress that are both within Istio. Sometimes there are certain tools that will handle service-to-service traffic, but not on the edge. Istio actually handles everything from the edge to service-to-service. It also does error handling, retries, and circuit breaking logic. And you can also inject fault in your cluster to do some like minor chaos engineering if you need to. So these are some primitives that Istio has that will give you a better idea how Istio does this thing. So they have an idea called virtual service. Virtual service, so Kubernetes world, you have an idea of a service. Service allows other people to access your particular application. With a virtual service, then you can get more control over which version of the service you're trying to talk to. In Kubernetes service, let's say the service handles 4 versions of your application. It will just do round robin if you make a request to the service. With virtual service, you can define exactly which version you're trying to talk to. We're going to see a quick demo of it in a second, exactly how you can control traffic going to different services. Destination rule also basically defines which version of the application you're trying to get to. So you define a rule for a destination. Service entry, we're not going to see this today, but service entry is when you're trying to let one of your service talk to a service outside of your cluster, like a call API call to a different server. So if you believe that you have a rogue service in your cluster that is trying to make calls to somewhere else that you don't want to allow, you can set a policy that will stop that from happening. And gateway is where you have people making requests from outside to your cluster, from a browser, from some other application as an API. And gateway will then control what can be called from outside to your cluster. Also, anything you can call from your cluster to outside. So gateway is in the 2 gates of the edges of the cluster. And finally, the idea of sidecar. Sidecar, again, Envoy is a sidecar. And sidecar will then catch any request trying to go to your service before it can reach the service. It will go through the sidecar. And sidecar then strip out metrics and policy checks before it reaches your actual service. For telemetry, so Istio's mixer that collects the telemetry by itself is stateless. It doesn't really store anything in mixer. It has adapters. As soon as any telemetry comes in, it will just pass on to the adapter it has. It can have adapter for Prometheus, for Datadog, SolarWinds, or anything. You can actually create your own adapters as well if you have some other service that you use. So adapters are modular and extensible. You can create your own or use some from third-party ones. If you're, for example, if you're using Datadogs, you can just have an adapter for Datadog, and it'll just send the data to Datadog server without you having to do any more in the code. So performance and scalability. So Istio also can do code-level benchmarks for you. It can send synthetic end-to-end testing to make sure that your service, the timing for your service doesn't go down or like up if it's bad. And finally, security, right? It can have traffic encryption to defend against man-in-the-middle attack. So again, if you believe that in your cluster, every single party in the cluster is where they should be, then you don't necessarily need the security policies. But if you think there could be some sort of man-in-the-middle attack, you can enable security, and then it will be mutually TLS certificate authenticated. So we're going to talk about a quick demo in a second. So So the application we're looking at, it's a microservice-based application. It has a product page, that's the front end. And then it has reviews, that is 3 versions, V1, V2, and V3. You have a details page, and you have a ratings page. V2 and V3 of reviews page calls the ratings page. So before we talk about anything else in the demo, we're going to first install Istio. So if you want to install Istio, you have a couple of options. Number 1 is manually installing Istio by installing the CRDs. And number 2 is using a Helm chart. So if you're using Helm, you can easily install Istio in your cluster using the Helm chart. And finally, the managed Istio. I think Alibaba Cloud, Google Cloud, and IBM has a managed Istio service. Again, they don't necessarily do anything magically different, but only thing I think they can offer is anytime Istio updates your cluster, you can just click another button to update your Istio. So again, this will be like dashboard look like on IBM terms. I work for IBM, so I have a cluster from IBM. But I think Google and Alibaba also has it. So you can just come here and click to install Istio. It will just install Istio. The demo I'm showing, I already have Istio installed. So if you have Istio installed, and so everyone can see it, right? Should I make it bigger? Bigger. You'll never get it right size in your. OK, how about now? Big enough? Well, almost? OK. Maybe a couple more. Why not? OK, so if you have installed Istio on your cluster already, it will look something like this. You will have a namespace called Istio system. And I already installed Istio a couple days ago to run the demo to see if everything's still working. And I'm typing in KL. I aliased kubectl to KL because kubectl is allowed to type. So if I'm typing KL, that is equal to kubectl. So I'm going to type in KL a lot. And get pods, I have nothing running at the system right now. Another thing you're going to see, show labels. So you're going to see on my default namespace, I have a label that says Istio injections equal enabled. So what this means, every time I'm going to deploy a new pod, Istio is going to automatically come in and inject the sidecar, Envoy sidecar onto my pod. So first thing I'm going to do, I'm going to deploy the application. So the application I am trying to deploy is this. And so this application is basically the 4 microservices we looked at. So I have the product page service. I have the deployment reviews. I have the ratings. And finally, I have the details. So I'm going to go ahead and deploy. And this is going to go ahead and create deployment service for all my services. If I do a kl get po, you're going to see that it's initializing. And one thing you're going to see that in the ready column, I have 0 of 2 instead of just 0 of 1. It's because each pod is having 2 containers instead of 1. It has the Envoy sidecar also jammed into it. So right now, everything is running. So kl get service dash and Istio system. And my application should be running on Istio ingress gateway at this external IP at the product page. So this is the URL this should be running in. And I refresh the page, I get nothing. I get nothing because by default, Istio, although the service is running, Istio blocks any traffic from coming in from outside. So if I want to enable that, so I have to also create gateways, that one I talked about earlier. So I have to create gateways so that Istio knows to let traffic coming through with this particular URL. So I'm going to let product page URL and all other URLs open up. So kl apply -f 02. So once I have the gateway in place, if I refresh the page, the website will show up. And this is a website that has, again, a couple of book reviews. If you see no stars here, that's review version 1. If I refresh the page a couple of times, eventually I'll see reviews with red stars and black stars. So black star is version 2, red star is version 3. So that's the 3 versions of reviews we have. OK, and finally, we also need to actually have destination rules so that when we're doing named virtual services, we know where to send our traffic. And this will just create the destination rules. Now, if I refresh the page a few times, you're going to see it just randomly chooses between no stars, red stars, and black stars. Is because right now, Kubernetes DNS server is just resolving on round robin where to send the traffic to. But we probably want to control where we send our traffic. So let me quickly go to the next one. And here, we're going to first send all our traffic to V1 version of all the apps we have. So that's how it looks like. So we're just choosing the subset v1 for each of the service I have, for ratings, for reviews, for product page, and for details. Okay. So once I did that, if I go back to the app and refresh the page a few times, you're going to see I keep on getting reviews version 1, no stars. And let's see what else we can do with this. So oftentimes, when you're deploying an application, you want to probably have some sort of control over, let's say you want to implement a new experimental feature. Some users who chose to sign up for the beta features, you want to show them that feature. Right now, if you want to do that, you probably would need to make some code changes on your application level. You want to say if the header has certain flags, send them to this traffic. With Istio, what you could do, so right now what we're saying is if there is a user that's name is Jason, show them v2, else keep showing them v1. Anyone named Jason here, by the way? No one named Jason. Perfect. Cool. We can do all sorts of things to Jason now. So if the user's name is Jason, show them v2, else keep showing them v1, and we're extracting this information from the header that the user sends. So if I apply this and come back here and refresh the page, since I'm not logged in, I said show them v3 if they're not logged in. So showing them v3, but if I come in here and try to log in, I'll start seeing v2. So any kind of features you set up, and you can do things for other things as well, like what browser they're coming from. Let's say you have a browser that your application doesn't look particularly well in, for example, Internet Explorer. So you can create a different version of your application for that, and if the user has a header tag that says we're coming to your application from IE, you can show them a different page, maybe with less JavaScript. Okay, so we did that. Next, let's see if we can inject some fault into our application. We have this already. Okay. So we want to test if the user's name is Jason, we want to inject a 7-second delay into our application. So what we're saying is, again, the same idea, but if the user's name is Jason, we want to send them with a 7-second delay. So how does that gonna? So if you come in, other way. So let's sign out real quick. So if you sign out, refresh the page, you're going to see the page load right away. But what if I am Jason? Then all of a sudden, my page is going to keep loading, and it's going to fail in about 6 seconds. So right now, we get product page are currently unavailable for this book. So one thing we don't know about our application yet, but let's just quickly take a look what's happening, why this is happening. Go forward. Also, these slides are going to be available, so if something doesn't make sense, I actually wrote down what is supposed to happen. So in the fault injection, we inject a delay for a specific user. And between our application, we have a string timeout set to be 10 seconds. We did a 7-second delay, but it's still failing. The reason it's failing, because on a different part of the application, on the product page, we're saying we're fixing a timeout of 3 seconds on the code, and we're doing 2 retries. So if I refresh the application one more time and open up my inspect, and on the network side, okay, if I refresh the page, you're going to see that the page actually refreshes in about 6 seconds. Where's the time? 6.05 seconds. So that's why it's happening. We have a 3-second timeout, 2 retries, 2 retries happened, it failed. So in one part of the application on the microservice, we set a 10-second timeout, and the other side, we are putting 3-second timeout for 2 retries. So this is a bug that will be almost impossible to find out if you just tested the individual application separately. On a microservice chain, you can do this kind of testing. So let's change this with a different timeout. Right now, we're doing 2.8-second timeout, and if I refresh this page now, you're going to see in about 2.8 seconds, the application comes back in about 2.87 seconds. OK, that's working great. Next, let's see if I can then stop my user Jason from seeing any reviews at all. So if the user Jason tries to access ratings, throw them 500 directly. Don't show them anything at all. So if I make that happen and go here and refresh the page, we're going to see the rating service is currently unavailable. So again, you can do this like testing on this individual subset of your users without actually affecting the entire cluster because you're not changing your code. You're also not affecting the entire application. You're just individually targeting certain part of the application. OK. Oh, not timeout yet. Hold on. 4. OK, this one is actually really important. When you're doing deployment, if it's a very crucial version of your application, you want to test that application works before you roll it out to everyone. You want to do something like a blue-green or a canary or A/B testing. And in Kubernetes world, it's actually quite difficult how you would go about doing A/B testing or a blue-green deployment. So in Kubernetes, let's say you have 2 versions of your application at the same time. One have 5 pods running, and one has, say, 1 pod running. So it will be 5-to-1 ratio. You can't really control exactly how much goes to where without digging too much into Kubernetes like API itself. With Istio, what we can do then, we have, let's say, 2 versions of the app running right now. So let's send everything back to V1 of the application. So everything is back to V1. If I refresh the page a few times, you're going to see V1 is just popping up, nothing else. And now we want to slowly shift our traffic from V1 to V3. And the way we want to do it is first send 90% of the traffic to V1, 10% to V3. And if that doesn't fail, eventually we'll ramp up V3 to 100%. So right now, I just applied this, and it should be 90-10. If I refresh the page a few times, you're going to probably see a red star, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I did 10, didn't do it. Hold on, keep doing. Oh, boy. Hold on, let me test again. Let me do 80-20. Hopefully, that will kick it in. Oh, wow, first try. Look at this. OK. So I expect about like every 10 tries I do, I should see 2 of them being red. And in average, so if it's a long-term traffic, you'll see about 20% of them being red. Let's do 50-50. Right now, we expect about like half of it being red and half of it being no stars. And again, it's not 100% accurate, but it's approximately close enough. OK, cool. And finally, now we have seen the red star working it pretty well. We could do send every single traffic to that version. And now we send everything to red, and red is going to work. So again, I'm doing it manually here. If you're using something like Spinnaker, you can actually set up configuration where Spinnaker will automatically start shifting traffic slowly. And if it sees an error, it can roll back as well. So you can put this as part of your deployment pipeline as well. OK, so next, let's OK, so this test, what you're going to want to see is that what happens if we want to inject some sort of delay for testing. We can just add a delay between my reviews and my ratings. So I can say kl apply -203. So what am I, the config I just applied is basically just saying every time you want to call the rating service, add a fixed delay of 2 seconds and 100% of the traffic that's coming in. So let's say you build an application, test it locally, everything is working great because all your databases are in the local file system exactly next to each other. But in distributed system, sometimes database connection takes days to connect. So on your local testing, you said, oh yeah, microservice, our testing takes 500 milliseconds. You put it into production, all of a sudden that same connection is taking like 8 seconds. Then you don't exactly know, my testing worked just fine. But with this, you can simulate, what if I have a delay between this to that service because I have a database in between? So I'm adding a 2-second delay here. And if I just refresh the page, you're going to see that is the loading for about 2 seconds. Right now, about 2.14 seconds, and just loaded this page. And what if I also want to add a timeout on our reviews page for like a half a second? 4. So what I'm saying is, if I'm trying to reach any reviews v2, add a timeout of 0.5 seconds. So just remember, between reviews and ratings, I have a delay of 2 seconds. Reaching reviews, I have a timeout of 0.5 seconds. So what do we expect? If I refresh this page, I want to see that in about half a second, its reviews is timing out. But if I refresh again, you're going to see that reviews is timing out, but in about 1 second. This is happening because, again, remember here, we had a timeout of 3 seconds and 2 retries. We overrode the timeout on the code by adding our own timeout on top of 0.5 seconds. That is happening twice. And we end up getting 0.5 times 2 as 1 second timeout in the reviews. So this was fine, all for traffic management within service to service. What about cluster level policies? With Istio, you can do that as well. So okay. Okay, 0, 2. So I'm going to, again, go back to my experimental JSON going to v2 and everyone else going to v3. And let's look at a policy we can set at cluster level. So this is a policy we have, and we're saying anything that is trying to reach v3 of reviews, deny that request. Doesn't matter where it's coming from. So entire cluster, if you don't want anyone to reach v3 of reviews, then you can set a policy on the cluster level that will deny before it can reach that particular service. So I just created 3 new primitives on Istio. One is deny reviews handler, and you have denies review request and deny reviews v3. These are just names we just gave it. It's just rules, instant, and handler we have created. So if I go back here now, and if I, let's say I'm JSON still, so if I refresh the page, I should see the v2 stars. But if I log out, all of a sudden I should start seeing ratings is currently unavailable because I'm disallowing anyone with the version v3 reaching anything in my cluster. Let's delete this particular service. OK. And so this is service level, cluster level policy we can set. We can also set cluster level whitelisting if you want to set anything like that. So on our cluster, we can say anything with the label v1 and v2 is whitelisted. It says blacklist false, so that means whitelisted. So anything with v1 and v2 is whitelisted. Everything else is blacklisted by default. So if I apply this rule, the end result on this case is going to be exactly the same as the last one, because before we denied v3, now we whitelisted v1 and v2 and denied everything else by default. So if I go the other way, if I refresh the page, you're going to still start seeing the same thing. Ratings is unavailable. If I sign in as JSON, you're going to start seeing black stars. OK. So I'm not going to delete that yet. And finally, we're going to look a little bit of what kind of telemetry you can generate with Istio. And so first things first, we have this gateway URL set. So gateway URL is the URL that we've been using to access our application on the cluster here. And what else we want to do? You also want to run a curl on our product page. We're going to just run a curl continuously on this product page so that it can generate some load or request. And we're going to look at this tool called Kiali that comes also built in with Istio. And Kiali allows you to look at your cluster in a view that is usually not available in Kubernetes easily. Kiali also works with pure Kubernetes. But with Istio, we didn't change any code, but we'll still generate this data for Kiali. OK. And Kiali is a service that's running on my Istio namespace. So kl get service -n Istio namespace Kiali. And it's running on port 20,001. So what I want to do is just port forward that port so that I can access this from my local host. And that is my handy-dandy cheat sheet right here. So I start port forwarding that port. Finally, I'll just copy this URL, and I should be able to access this from here. So Kiali, and I can look at the graph that it generates. So right now, remember we said v3 of the application rating should fail. We should get a 400. So every single request that we've been generating had been going through v3, and it had been failing. So what we want to do, we want to see that we're going to fix that particular rule, and we'll see that our application starts turning into green. So I'm just like setting a new rule to send every single traffic to version 2. instead of v3. So if you wait a few seconds, right now everything is still going through v3. When then every 15 seconds it updates. So once it updates, we should start seeing that requests are going through v2 and it's turning green instead of red. So hopefully this will work. Oh boy. So you're gonna all intently stare at it until it starts working. Oh, here you go. We started seeing some things going through ratings. Eventually, I can give it a little bit of push by just refreshing a few times myself. Oop. So eventually, we're going to see no more traffic going through v3 and everything going to v2. So again, KLE is one of the many things that Istio comes with. It also comes with Grafana, Jaeger to see tracing of entire request, end-to-end. You can also, so v3, now no more traffic is going through v3, everything is going through v2. So this was just like a quick overview of all the things Istio in terms of demo. So we're going to look at a couple more slides, then I have time for your questions if you have any. So more. Okay. All right, final thoughts. So we saw a bunch of things Istio can do and almost looks like for free. But one thing to keep in mind that there is no free lunch in this world. All the things Istio can do, it runs on your cluster, uses some sort of CPU. These are a couple of the really good articles that came out in the last month. They're basically benchmarking Istio versus Linkerd and talking about what use cases are better for Istio versus Linkerd. In short, in a Cliff Note version of this particular articles would be, if you need every single thing Istio comes with, Istio is great because it's featureful. But in the same time, if you just want just a service mesh part, the discovery part, Linkerd is probably going to be faster for you anyway. So just because I have a little bit of time with Istio, I'm not going to just come in and say Istio is the greatest thing in the world. I would rather give you more options so that you can make the decision for you. So again, Linkerd is also, they rewrote Linkerd at Linkerd 2, they rewrote the entire application, renewed the entire application so that it's better in performance. Also in Istio, they're rewriting Mixer as with C++. So we are hoping to see a lot more performance improvement there as well. So in the upcoming few months, we're going to start seeing newer benchmarks in terms of those. So the key takeaways from this talk, if you take anything, would be that service mesh and Istio that when we showed extends Kubernetes capabilities in some ways. And it can make some very difficult Kubernetes things a little bit easier to manage. And finally, thank you. You came in and listened to me and watched me try to solve some of this issue that I was having a little bit. And I'd love to hear your stories, your comments and questions if you have any. And thank you. If you need to have any more questions, please find me at moficodes or after the talk here today. Anyone has any questions? I actually had time for about 6 minutes time for QA if you have any questions in general. Cool. Yes. The mic is behind you. Sorry.
I have a question on load balancing.
Yes.
And so load balancing, not just random round robin or something that is based on latency of the service and also memory usage, CPU usage. Can Istio be used for managing custom load balancing based on how the services are doing in the system?
So the question is, if I understood correctly, that if your one service is getting slow, you want to, if
Yes.
Istio can handle.
Yes.
As of now, Istio doesn't really do load balancing on that term. Istio does load balancing on weights. You define what kind of weights. But you can also check on logs if your service, so if you want to write custom controller, if you have some services getting too slow, you can kill those if you want. So you can do that way, but Istio itself automatically won't do that.
Okay. And
Okay.
One other question is how much latency does Istio add with the proxy?
So in the latest, Istio adds about 12 to 15 millisecond on the Envoy proxy. In total, you're still looking at less than 30 millisecond total latency.
Okay. Thank you.
Yeah, no worries. Thank you. Any more questions? All right, I think with that, I think I can give you some time back for you guys to enjoy the conference and other things. Thank you so much.